I'm going to try to be as efficient as I can be. Problem number 1, common bases, happy places. So I'm going to change that base to 3 cubed, x plus 2. And I remember if I have a power to a power, I have to multiply those bad boys. So I distribute. 3x plus 6 equals 3 to the 2x. Now the whole purpose was to get these to be the same so that this has to equal this. So 2x equals 3x plus 6. Subtract 3x, trying to isolate my x's. Negative x equals 6, so positive x equals negative 6. That's problem number 1. All right, let's go to this one. The 2 shall become 1 if I have a log, same base, log, same base, separated by addition. The 2 shall become 1 log. By addition means multiplication, so this essentially gets multiplied through there. So we get x squared minus 2x equals 3. Now, this one up here, I'm just going to jump around a little bit. This one here, common bases, happy places, not happening. So that's when you slap a log on there. Then you slap a log on there. Now when students start learning, oh, I slap a log on stuff, they start doing that to these, and then that's where the ship starts to sink a little. Because this already has a log on this side, so you have to look at this differently. Base, exponent, answer. So 2 cubed is 8 equals x squared minus 2x. So I'm going to subtract 8 from both sides. And hopefully they make this so it's factorable, and this one it is. If it's not, you have to stuff it into the quadratic formula. So x equals 4 or negative 2. But Zephron, thank you Zephron, reminded me at some point, got to check these answers, because if you plug that in to here, a logarithm, and it's a negative, negative 2 minus 2 is negative 4, you can't have a negative here, ever. So that throws that out. Put a 4 there, no problem. Put a 4 there, no problem. There's your only answer. This is called an extraneous root. Letter C. Again, 2 logs. These are natural logs, but they're separated by addition. So the 2 shall become 1 by multiplication. So we distribute this through. 3x plus 12 equals natural log of 63. Now we kind of know what to do with this. This has to equal this. So 3x plus 12 equals 63. Subtract 12, I get 51. Divide by 3, I get x is 17. Check it. Positive stuff, no problems. There's my winner, chicken dinner. Back to letter D. I've already slapped logs on both sides. When you have an exponent like this in a logarithm, it can come in the front. It's law of 3. Log of 10. If you check it out, if I just go log of 10, I'm going to get 1. Whoopsie. And the reason is, if I really looked at it, log of 10, there's an invisible 10 here. It's asking you 10 to the what power is 10. That has to be a 1. So this always equals 1. So I get 7x in front of 1, which is just 7x, equals, now I'm going to go log of 12, 1.08 I'm going to call it. Divide by 7, because I'm going to divide both sides by 7, and I get x is 0.154. All right. Next one, let's divide both sides by 5, simply because we can. We get log base 3 x equals 8. And now we go to our basic definition of what a logarithm is. Base, exponent, answer. So 3 to the 8th power equals x. You can leave it or figure it out on your calculator. Letter F, let's simplify some stuff. So I get 3 times 4 to the x power equals 45. Now some people are going to want to make this 12. Don't do it. Remember PEMDAS? Exponents come before, so don't you dare make that a 12. We're going to divide by 3, so I get 4 to the x equals 15. Now again, common bases, happy places, can't do it. So we're going to slap a log on here, slap a log on here, bring that exponent in the front, and get to work. So log of 4 0.602. So we get 0.602. Now I said put the x in the front, but you can put it on the back here. Log of 15 is 1.18. So I'm going to go divided by 0.602. And I get x is approximately equal to 1.95. We'll round it to there. All right. Now, let me get some formulas written down. Okay, number 2 says find all the missing sides and angles of the following triangles. Well, you can tell we have side A, we have side B, we don't know side C. You cannot use Pythagorean theorem because you need a 90-degree angle here. There's all sorts of fun things you could do with that 120 in the 30, 60, 90 world in geometry, but we're going to stick with what we've been learning, law of sine, law of cosine, and see what we can do. So I'm going to stick with law of sine because I got angle C and side C. No, I'm not, because all I have is this. Yeah, so no, not going to work. But I do see that I have angle C, which this is the only one that uses angle C. It's right here. So I'm going to pick this bottom one and see where this goes. So C squared, we don't know what it is, equals A squared, which is 18 squared, plus B squared, which is 10 squared, minus 2 times A times B cosine of C, which is 120 degrees. As you can see, we're going to find C. I'm going to pause this so I don't tear. I do want to point something out. In my haste, I typed in cosine of 120, and I got this weird number which triggered, whoa, wait a minute, you better check your calculator for mode. I was in radians, and I changed it to degrees, and so this should really be your answer, negative 0.5 for just cosine of 120. Let me pause this. All right, so whittled it down. Got to here. This ends up being negative 0.5, and this negative times that negative gives us 2 negatives, which ends up being plus. Be careful there. I'm going to take the square root of both sides. So here we go. And I get 24. I'm going to approximately 24.6, we'll call it. 24.6. And now that we have all 3 sides, we can easily calculate an angle using law of sine. I'm going to use this and this. So sine of 120 all over side C. And I'll just go with letter A equals sine of A all over side A. Now we can look some stuff up. Sine of 120, 0.866. I'm going to multiply that by 18. 15.6, I'm going to call it. I'm going to multiply this way and get 24.6 sine of A. Divide by 24.6, divide by 24.6. I get sine of angle A is, divided by 24.6, 0.634, I'll call it. So now I'm going to grab my calculator and do that second sine business. So second sine, 0.634, 39.34. So approximately angle A, 39.3, we'll call it. And so if we know that this is 39.3, we add it to 120. And then we're going to subtract that from 180. It's going to be negative, but 20.65. So angle B is 20 point whatever, 7-ish degrees. That's what angle A is. Big problem. I think letter B is going to be a little bit easier because I got angle A and side A, which is leaning here. So I'm going to go sine of 40 degrees all over side A. I'm going to pick side or angle C because I have side C. So that's 7. I'm going to go sine of angle C. So here we go. See how important it is to have your calculator set in degree mode. So that's sine of 40 degrees is this. So I'm going to multiply straight across times 7. 4.5 equals, and I'm going to multiply that way, 5 times sine of c. Divide by 5, divide by 5. I get 0.8999 equals sine angle C. So second sine 0.899, we'll call it 64. Looks like they want it to be whole numbers, so 64. And I'm going to add this to 40, so it's 104. Subtract that from 180, 76. That's what this is. And, oh, we still need to find a side, which is side B. And if we can use the law of sine, I'm going to use the law of sine. Now, I've already used this stuff, so I'm going to use it again. So sine of 40 degrees all over side A, which is 5. And now we're going to go sine of 76 degrees over side B. And so here we go. Sine of 40 was 0.643, so 0.643. I'm going to multiply it this way, so 0.643b equals, and I have to multiply that by that. Alright, so sine of 76 times 5, 4.85. So I can divide this by 0.643, same thing over there. So divided by 0.643, 7.55 approximately. Or 7.6. Good enough. Alright, so this one's a little unique because they give us a 90-degree angle. Notice that. That means you don't necessarily need this or this. This will work, but maybe there's a little shortcut here. It says, find the indicated angle of the following triangle. So they want us to find theta. So as you can see, this is a right triangle. So this is my hypotenuse, this is my opposite, and this is my adjacent. So I'm going to use this one and this one in relationship to that angle. Well, that means cosine of that angle is adjacent over hypotenuse, and I'm going to go, I'm going to go second cosine of whatever this decimal is. So 4.4 divided by 11.4. So here we go. Second cosine 0.4, enter. 66.4. So theta is approximately 66.4 degrees. Took advantage of that 90-degree angle there. All right, vector land. Here we go. Take vector n, which is right here, 1, -5. This should be easy street. Subtract double this. So we're going to put a 2 in front of there, distribute. So we get -6, 14. And now this just hits this and hits this. So this is 1 plus 6, which is 7. And then -5 minus 14, which is -19. So there's your answer for letter A. This is just simple. Multiply vector n by 6. It's like putting a 6 there and distributing. So this is 6, -30. Simple, simple. This is just kind of busy work. So multiply letter m, or vector m, by 5. So take that 2 out, put a 5 in there, distribute. We get -15, 35, plus, now 4 times n, distribute, 4, -20. -15 and 4 is -11. 35 and -20 is 15. That's it. All right. Probably the last one before I finish this part 1 video. Remember, I is equal to 1, 0. J is equal to 0, 1. Those are called unit vectors because their lengths are 1. And it just says multiply I by 4, which means we get 4, 0. And then subtract, I'm going to keep that separate. If you multiply this by 2, so we get 0, 2. So 4 minus 0 is 4, 0 minus 2 is -2. Notice you could just take that first thing, put it here, put the second thing, put it there, kind of works. But now it says find the magnitude and direction. Magnitude is just the length of the hypotenuse. 1, 2, 3, 4. Down 2 right there. So that's 4, that's negative 2. 16, that's that squared, plus 4 is c squared, so we get 20. So we take the square root and we get the square root of 20. Now if you break that down, you get 2 square root of 5. I don't really care which one you use, but there's your magnitude. Now what the heck is direction? Direction, like we talked about today, is how far you spin the spinner. Well, I'm going to take tangent, because this is opposite over adjacent. I'm going to go tangent of this angle. I'm going to call that theta, would be opposite over hypotenuse. So now I'm going to go second tangent, negative 0.5, because that's what that reduces to. And it's telling me, no, you didn't. All right. Second tangent. I might have used the wrong minus button. Negative 0.5. There we go. So theta is negative 26 point, we'll round that to 26.6. That means that's what this is. To get to that situation, go down 26.6. But they want to know how far you spin the spinner to get there. So I'm going to take 360 minus 26.6. 333.4. So 333.4 degrees ends up being the direction of Q. All right, find the component form and the unit vector in the same direction as Q. So it's this picture saying find the component form. Well, there's a formula, and it's just this, if you recall, which takes care of it for you. So really, you take the original vector, which is 4, negative 2, and you put it over the magnitude, which is the square root of 20, square root of 20. Now, if you did reduce it, you would get 4 over 2 square root of 5, negative 2 over 2 square root of 5. But for some reason in this world, they typically leave it alone and they don't worry about getting that reduced or getting the radical out of the denominator, but you could take the time to do that. I'm just not going to take up video time to do so. So that ends part 1 of the review video.